This is trigonometry, and these are all you need to know about the trigonometry introduction. We are saying that in trigonometry, it is recommended to give your answer exactly or three significant figures. You can give it as the exact that's how you got it while calculating. However, you can as well give it into three significant figures as appropriate, unless instructed otherwise. Point 2, answers in degrees should be given to one decimal place. Whenever you are giving your answer into degree, then you should consider one decimal place. And then now the basic trigonometric ratios, we only have like three basic trigonometric ratios. And the first one here is sine, cosine, and tangent. So each of these are related angle of right angle triangles. We are dealing with right angle triangles here when talking about trigonometry. So each of them are related to right angle triangle. We wanna use any of them depending on what we are asked about in the question. Now each of these are related to the triangle to the ratio of length of two of its sides. For example, if you look at this triangle, this is a right angle triangle of the vertex A, B, C, and we are taking this angle as our reference. You notice that if you take this angle as our reference, then the opposite side to the angle is what we call the opposite. Then the opposite side to the right angle is what you will always call hypotenuse. Then the adjacent side is the side that is next to the angle of reference. If you consider this other figure, we have this angle A, and it is opposite to this other side. So you'll notice that the difference between the first triangle and the second triangle is the adjacent was here, but now this is the adjacent. Now they are twisted. It is opposite because of this angle. This side is opposite. If you look at them, they are opposite. And also if you look at this side of right angle, it is opposite, which is called the hypotenuse. Then this line, which is next to the angle of reference, is always the adjacent line. Then there is a note here that the longest side, which is always opposite to the right angle that I have shown you, is called hypotenuse. It is called hypotenuse. And then the opposite side of the angle is called the opposite. Then the side next to the angle is called the adjacent. Let's begin with the tangent. What or when do we use tangent? So tangent is used like in this figure. We have a right angle triangle A, B, C, and we are now referring to this angle. When we are referring to this angle, then we are saying that tan C, which is equal to the length of opposite side over the length of adjacent side. So opposite over adjacent when we are referring to the angle at this point. Then let's do these examples. Calculate the size of angle BAC in each of the following triangles. From now on, we have triangle ABC and we need the size of this triangle. So we are required to use tangent to calculate that side. So we'll do, solution is here, that tan x is equals to the opposite, which is 4 centimeter, divided by 5, which is the adjacent. So x is equals to the tan inverse of 4 over 5. Use your calculator to find the tan inverse of 4 over 5. Use the calculator to find the tan inverse. So if I use my phone to do tan inverse of 4 over 5, I'm having 38.7 degrees. So I can wrap this and put it on this other side. So I've given my degree to 1 decimal place. For B, Roman 2 solution is we are asked about the tan, the angle. So again, tan x is equals to opposite over adjacent. So x is equals to tan inverse of 3 over 8. I'm having 20.6. Sorry for that. Should be 8 over 3. Yeah, so 69.4 degrees. B is calculate the length of opposite side, QR. So we need the length. We have this angle, then we are asked about that, which is the opposite, then we have the adjacent. So it says that tan of x is equals to opposite over adjacent. So tan of 42 degrees is equals to opposite, which is P over adjacent, which is 6. If I cross multiply, I have 6 tan 42 degrees should be giving me P. So 6 I'm getting 13.7. Centimeter. That is the significant figure. Then lastly, calculate the length of the adjacent side xy, this side here. So the solution to this is that let me see if that question is complete. I need to have the angle here is 35 degrees. Good. So I will do tan x is equals to opposite over adjacent. So tan of 35 degrees is equals to 6 over z. So if I cross multiply, I get z equals to 6 over tan 35 degrees. So I'm getting 12.7 centimeters. So yes, that is how you can calculate problem related to tangent. Let's go to cosine. Let's go to cosine. So cosine is given as length of adjacent side divided by the length of hypotenuse. For example, if you use this right angle triangle XYZ, if you are using this angle as a reference, then this becomes the adjacent, and then this is the hypotenuse. For example, if you are asked to calculate the length of XY, like in this figure, you are asked to calculate the length of XY. So for you to do that, you say that in this figure, if this is what is asked of us, we have the hypotenuse, and then we have the angle, then we are being asked about the adjacent. Hypotenuse and the adjacent. So you use cos. You say cos 62 degrees is equals to adjacent, which we do not know. So you can say adjacent xy divided by hypotenuse, which is 20. So if I cross multiply, I have xy equals to 20 cos 62 degrees. So 20 cos 62 degrees is given as 13.47 centimeter. If I want to write this can give it to this significant figure. However, this is still okay. 2 decimal place. And then calculate the size of angle x. So you say on this example B, say that cos x theta, cos of x degree is equals to the adjacent. The adjacent is 5.3 divided by hypotenuse, which is 12. So x itself is the cos inverse of 5.3 divided by 12. So 5.3 divided by 12, the cos inverse is 60. I'm getting 63.8 degrees. Getting 63.8 degrees. Let's go to sine. Let's go to sine. So for sine n, which is this angle, is length of opposite side divided by length of hypotenuse. So I think you can see how the difference comes in. Length of the opposite divided by the length of hypotenuse. Then opposite with reference to this angle is this, then the hypotenuse is that. So an example here is to calculate the size of the angle BAC. So you say the solution is sine x degrees is equals to opposite, which is 7, divided by the hypotenuse, which is 12. So x degree itself is sine inverse of 7 divided by 12. Let me do that. Sine inverse over 7 divided by 12 is 35.7. Then calculate the length of the hypotenuse, PR. Calculate the length of the hypotenuse. This is the hypotenuse, PR, then that is Q. So the solution is, if you look at this angle, we have the opposite, and now we are being asked the hypotenuse, and we have the angle, so we use sine. We say sine theta, we have sine 18 degrees is equals to opposite, which is 11, divided by q, which we do not know. We cross multiply, I have q sine 18 degree equals 11. If I divide both sides by sine 18 degrees, sine 18 degrees, so even with q is equals to 11 divided by sine 18. I'm getting 35.6 degrees. So yes, that's how you can use trigonometry to calculate sine, cosine, and tangent. Let us do a conclusion of a formula to use. In conclusion, yes, so in conclusion, for you to memorize trigonometry, you need to know or master SOHCAHTOA. SOHCAHTOA. That is the formula you're gonna use to master them, where S stands for sine, and therefore the formula for sine theta is opposite, which is this, over hypotenuse. If you go for this, cos, that is ka, which means cos theta is given as adjacent over hypotenuse. Then finally, tan theta is given as opposite over adjacent. So yes, that is all you need to know. And for more information, you can go to our website. Maybe you want to find us, I'll pin the link below this video, and you can look at the services that we offer. You can contact us. That is Bright Star Homeschooling and Tuition. Bye bye for now.